The 4th of December 1990. It's a cold, windy morning in Garching, a small town in southern Bavaria. In front of the headquarters of ESO, the European Southern Observatory, the flags of 8 European nations flutter in the wind. Inside, the ESO Council is meeting. Delegates from all of the ESO member countries have gathered to decide on the very important question of where to place the world's biggest optical telescope, the ESO 16-meter Very Large Telescope, or VLT, now in the final planning stage. The ESO VLT is the flagship project of European astronomy. In order to fully exploit the enormous observational potential of this super telescope, the Council must select the very best site for it. All delegations agree the VLT should be built on Paranal, an isolated mountain peak in the heart of the Atacama Desert in Chile. The dry Atacama Desert in Chile is known to have some of the best sites in the world for astronomical observatories. To the west is the cold Humboldt Current in the Pacific Ocean. The water vapor in the air condenses and forms clouds over the ocean along the coast. To the east lie the very high mountains of the Andean Cordillera. They too serve as a barrier, stopping all clouds approaching from that side. In the middle, there's a narrow strip with an extremely dry climate, the Atacama Desert. There are very rarely any clouds here. It's an ideal site for an astronomical observatory. This is where ESO has been operating one of the largest observatories in the world for more than 20 years. There are now 15 telescopes on the La Silla mountain. But to accommodate the new gigantic instrument, most of the other telescopes would have to be removed. So ESO had to look for another site for its VLT. It was to become the most elaborate search ever undertaken to find the site for an astronomical telescope. For several years, scientists and engineers looked for the best possible site for the VLT in the Atacama Desert. Their travels took them to high mountain peaks at altitudes above 5,000 meters and also to remote places in the very driest part of this desert area. Satellite images were studied in great detail to find the best sites where clouds are very rarely seen. The first reconnaissance showed that the very best sites were in the northern Atacama Desert, several hundred kilometers north of La Silla. ESO then decided to have a closer look at the mountains in that area. As early as 1982, Professor Lovolche, then Director General of ESO, visited this remote region.
And simply we decided to have a look at that area and see how it looked on the ground. And we then drove up there and found, in fact, that the lack of any vegetation at all was extraordinary. The transparency of the sky was extraordinary. And we concluded from that one certainly couldn't say, of course, that the site was good, because one had seen it only one day, but that it was worthwhile to make much more thoroughgoing investigation of Paranal itself, as well as of a number of other sites.
The most promising mountain was Paranal, in an uninhabited desert area about 130 kilometers south of the Chilean town of Antofagasta. Paranal's peak is 2,660 meters above sea level, and it's 12 kilometers inland from the steep Pacific coast. Careful studies were now needed to assess the observational qualities of Paranal. Astronomers call such a study site testing. The techniques and methodology for the VLT site testing were developed and verified at La Silla with the help of scientists from ESO's member countries. The work was coordinated by a site selection working group chaired by Professor Harry van der Laan, then at the Leiden Observatory in the Netherlands and later Director General of ESO. A small dedicated group of ESO people was installed on Paranal in 1983. It was their task to measure how good Paranal really is for astronomical observations. For almost 8 years they worked here day and night in the barren desert landscape under the blazing sun and the starry southern sky. It's thanks to their hard work that we now know that Paranal is the best site for the Very Large Telescope. The team, with Francisco Gomez, Daniel Maza and Alfonso Vargas, carefully logged the temperature, the humidity, the air pressure and the wind speed and direction. They measured the microthermal activity at ground level and also high above the mountains by means of ultra-sensitive temperature sensors and acoustic sounders. Here, Francisco Gomez checks the infrared sky emissivity with a radiometer. Readings were taken every hour, day and night, year in, year out. So-called differential image motion monitors were used to measure the sharpness of stellar images. They stand in the open air and are operated from a control room in a shelter. Very rarely did the team report clouds. They found that the sky above Paranal is clear for more than 350 nights and days each year. There's hardly any water vapor in the atmosphere, ensuring the best possible conditions for observations in the optical and infrared spectral regions. On night duty, Daniel Maza checks the data obtained with the differential image motion monitors. The data appear immediately on a screen. It was found that there is little air turbulence at Paranal. This means that the VLT will be able to produce extremely sharp images of celestial objects. The conditions are virtually perfect here. Of course, Paranal was not the only mountain to be investigated. A mobile ESO unit made measurements at quite a few other mountains in northern Chile. Roberto Castillo prepares the instruments before one of the trips to the remote desert sites. One of the mountains was Vizcachas, not far from La Silla. Measurements are still being carried out here. This service is very valuable for checking the observing conditions on La Silla. Comparative measurements were also made at the Carnegie Las Campanas Observatory 35 kilometers northeast of La Silla. These tests have produced important byproducts. With the new measuring techniques, astronomers at La Silla are now able to recognize and make best use of the rare periods when the air is extremely quiet, when it's possible to obtain exceptionally sharp images of stars and galaxies. This will make short-term forecasts for the observational conditions more reliable and therefore ensure optimum use of the VLT. Most important, however, is the conclusion that Paranal really is the very best site for the VLT. But how stable is the climate at Paranal? Can we really be sure that the excellent conditions which we measure today will also last? To understand the long-term stability of the climate in the Atacama Desert, astronomer and biogeographer Michel Grenon of the Geneva Observatory hiked through the desert for many years. He collected and registered samples of the scarce vegetation. The present and past distribution of desert plants, with their different needs for water and humidity, provides a detailed record of the evolution of the local climate over hundreds of years. This study showed conclusively that the climate at Paranal is quite stable, more so than is the case further south closer to La Silla. We now know that from the meteorological point of view, Paranal is the best continental site for astronomical observations. No other place on this earth has so many clear nights, but other factors must also be considered. The Atacama region is geologically active with frequent earthquakes. Geologist Fabien Bourlon analyzes the stability of the rock. Full knowledge of the geology of the Paranal area is important before the VLT observatory can be built here.
So, when you have finished your blasting operation, then we could use those devices to measure up the characteristics of Paranal Mountain.
At ESO's headquarters in Garching, the engineers Lucas Janssens and Jörg Eschwey need these data to ascertain that the mountain will be able to support the heavy VLT instruments and buildings.
As nearby as possible without damaging the equipment. And then I would...
Paranal stands relatively isolated and has the shape of a cone. This shape determines the wind flow over it and around it and ensures that there's very little turbulence in the air, which is vital for good image quality. 23 meters must be cut off the mountain top to create a platform big enough for the VLT. An important question is therefore how this change in shape may influence the wind flow over Paranal. To study this, ESO physicists have collaborated closely with the ESO Research Centre in Denmark, which has prepared a numerical analysis for the wind flow over Paranal. Equally important is the positioning of the individual buildings on the platform to make the best possible use of the prevailing wind conditions and minimize the turbulence induced in their aerodynamical wake. The ESO study has confirmed that there will be no significant change when the summit is removed. A view towards the Pacific shows the dramatic change in climate over just a few kilometers. Down there is the humid and cloudy coastline, while up here at Paranal the climate is dry and stable. Paranal is very well suited for the establishment of the VLT observatory, but it's not a friendly place, neither for humans nor for animals. Before the road to the top was built by ESO, even four-wheel drive cars had problems negotiating the steep slopes. When they failed, the equipment had to be carried up by the staff. In the early days, there was no electrical power. Solar panels and batteries were used. When the observatory is built, most of the power will again come from solar panels and wind turbines. ESO is very anxious to preserve the pristine nature of this site. There is absolutely no water at Paranal. Water from the Andes is brought to the town of Antofagasta, 130 kilometers to the north, by pipeline. From there, it's transported by truck on the Panamericana Road and then on to Paranal on the new ESO Road. Slowly, the camp at Paranal has developed into a more civilized place. Now, there's a reliable power generator and living quarters for the staff. That is also the domain of cook José Garcia, who, with the talents of a magician, produces delightful meals for the small staff at Paranal. Man is no longer alone on Paranal. There is a dog and a cat who live in peace and harmony. And the desert birds have also found their way to the mountain, attracted by the possibility of finding food at the camp. There are even some flowers here now, which are carefully tended by the staff. The construction of the VLT observatory will be a complex and difficult task in the desert. The only town in this harsh region is Antofagasta, and apart from some fishermen along the coast and workers in the copper mines, the region is uninhabited. The VLT observatory will bring a lot of life to this remote area. The site tests have been the work of highly motivated people, some of whom have made very personal contributions to the search. The chairman of the site selection working group was Jean-Pierre Swings from Liège in Belgium. Arne Aderberg from Lund in Sweden is one of the leading experts on site surveys. He spent many months in the Paranal area, and at Garching, Marc Sarrazin was responsible for developing the unique instrumentation used for the site tests and also for evaluating the data. In Chile, Hans-Emil Schuster led the team on the spot. How did he and his colleagues keep the motivation high among this small crew in such a deserted place?
They just did it. You would have assumed that other kind of people, they would just on array after 2 months, or yes. They wouldn't have. It's a question of motivation. Yes. Not giving them promises you cannot fulfill, but just convince them. You see, I think that's the whole secret.
And how does he compare this site survey with the one at La Silla 25 years ago?
That in this time in Paranal, also after 25 years, the site testing methods have developed tremendously. You can't just not compare what has been done here for the site testing and what has been done in Paranal. Not only the longer time, that is something else, but I'm really now talking about the method and about the instruments.
Conditions of the early 60s and the late 80s are incredibly different. It's that enormous experience in between. It's also much better communications, better transport facilities, more resources to fairly quickly build provisional roads and have safe and, relatively speaking, comfortable conditions.
Following the decision to build the VLT at Paranal, ESO is now preparing the mountain to receive the instruments and the associated buildings.
The VLT observatory on Paranal is a complete conception. The observatory will be built, essentially we start in 1991 blasting rock. We finish in 1999 with a completely equipped, functional observatory.
Paranal will be the most remote and isolated major observatory on Earth, an important asset which must be safeguarded. To preserve the exceptional quality of Paranal, the Chilean government has donated a surrounding area of 725 square kilometers to ESO, ensuring effective protection for the VLT against light pollution and mining activities. This will be the home of Europe's prime exploration base for astronomy, the VLT Observatory.